So we have this nice picture for 2014 FRQ number 3, and it also tells us this g of x relationship. G of x is equal to the integral from -3 to x of f of t dt. And anytime I see this relationship, I should immediately write g prime x equals f of x, because then when this says it's a graph of f, we can also say it's a graph of g prime. So first it asks us to find g of 3, so we're going to do g of 3 equals the integral from -3 to 3 of f of t dt. So we go to our graph of f, and what we are looking for is we're looking for the area under the curve from right here at -3 all the way to here, which is +3. So we can highlight the area we're looking for. We're looking for this triangle area. Okay, and then we also need to subtract this area right here from that triangle. It's under the curve, or below the x-axis. So we look at this triangle, and we see that it has a base of 1, 2, 3, 4, 5, and it has a height of 4, it looks like, or 1, 2, 3, 4. So it's a 5 by 4 triangle. So the area of that is 5 times 4 divided by 2, which is going to be 10. It's an area of 10. And then down here we have a triangle that has a base of 1 and a height of, that's going to be a height of 2, because this line has a slope of -2 down 2 over 1, down 2 over 1, down 2 over 1. So I just haven't drawn that picture very well, but this is going to be a triangle that is 2 times 1 divided by 2, which is just going to be 1. So then that means that our area is going to be equal to 10 minus 1, which equals 9. Okay, so now part B is asking about g, so we should look at a fresh picture here, because it's saying when is g prime, or when is g both increasing and concave down? So what we need is we need g prime to be positive, but we would need g double prime to be negative, right? So where is g prime positive? Let's look at those first. Well, g prime is positive above the x-axis, right? Because this is a graph of f, which is also a graph of g prime. So all over here is where it's positive, right? But g double prime, what is that going to be in terms of g prime? Well, g double prime is going to be the slope of g prime. So we need the slope of g prime to be negative, while g prime itself is positive. So we need g prime to be decreasing. This implies that g prime is decreasing. Okay, so we can see that g prime is decreasing here, and it's also decreasing here. And it's also, g prime is positive here, and it's also positive here, because the output is positive. It's above the x-axis. So we can see that this happens then from -5, from -5 to -3, and from 0 until 2. And then we will say, because g prime x is positive and decreasing. So that's our final answer, and we need to provide that justification to get full credit. Okay, next up, we have h of x is defined as being g of x over 5x to find h prime 3. So this is a way of sneakily working in the quotient rule, because we have a function divided by another function. So to find h prime x, we're going to have to apply the quotient rule here. So that will give us g prime x times 5x minus g of x times the derivative of 5x, which is just 5, and then all over 5x squared, and we have to make sure we square the whole thing, was the whole denominator squared. So then h prime 3 is going to be equal to g prime 3 times 5 times 3. We're just going to replace all our x's with 3's, minus g of 3 times 5, and then that's going to be over, okay, so remember that 5x squared is going to be 25x squared. We have to square both pieces. So this is going to be 25 times 3 squared. So let's take care of g prime 3 first. G prime 3 is on our graph, right? g prime 3, x equals 1, x equals 2, x equals 3 is equal to negative 2, right? So we have that this g prime 3 is equal to negative 2, and then obviously 5 times 3 is 15, minus g of 3 we did in part A. It asked us to find g of 3, and we said it was equal to 9. And let's say we were wrong about that. We would still get credit for using our same answer from part A. They will not double count us wrong. So g of 3 is 9, and then obviously we have times 5, and that's over 25 times 9. So then let's do a little simplification here. We have negative 2 times 15 is negative 30. And then we have minus 9 times 5 is going to be minus 45, and that's going to be all over 25 times 9. I might still need verification on this because I don't know how far we actually have to go in terms of simplification, but this actually doesn't end up being too bad because we get negative 75 on top. And then 25 is easy to multiply by because every 4 25s is 100, obviously. So 25 times 4 is 100. So then 25 times 8 is 200. So then 25 times 9 is 225. So just to play it safe, we'll just simplify it down to this at least, which also simplifies down to negative 1/3, but let's just, they have to accept this for sure. Okay. So part D is asking about a slope of this function p, where p of x is f of x squared minus x. So this is a way of them sneakily working in the chain rule, because to find p prime, we're going to have to do f prime of x squared minus x, and then we have to multiply by the derivative of that inside function, x squared minus x, which is going to be 2x minus 1. And what it wants us to find is p prime negative 1. So we get f prime negative 1 squared minus negative 1. And of course they throw in a negative 1 to make it so the sign is going to be confusing. 2 times negative 1 minus 1. So we got to be really careful here. Let's first say that this is f prime. We're going to get negative 1 squared is 1. And then we're going to subtract a negative 1, which is going to be adding, like adding positive 1. So we have f prime 1 plus 1. And that's going to be negative 2 minus 1, which is negative 3 that we're multiplying by. So we're really looking for f prime 2 times negative 3. So then what is f prime? Because we know that g prime equals f. So then g double prime equals f prime. So we're really looking for g double prime 2, which is going to be the same as f prime 2. So we have to go back to our graph. And our graph, this is a graph of g prime, so we need to look for our slope here at x equals 2. X equals 1, x equals 2. We've already dealt with this line before. We know the slope of this line is negative 2. So that'll tell me that g double prime 2 equals negative 2. And that's going to be the same as f prime 2. So we end up with negative 2 times negative 3, which equals 6. And that's our final answer. The slope of that line at x equals negative 1 is 6. Okay, that was a tough one. I might recommend that you watch that video again to make sure everything sank in. But yeah, that's it.